Hello guys, welcome back to my YouTube channel, and this is day 9 of June daily Leetcode challenge. And our today's question is a maximum value at a given index in a bounded array. So let me explain you the problem statement first. You are given three positive integers, an index and maximum. You want to construct an array nums that satisfy the following conditions. So we will be having these three integers, n, that is like the total number of elements that should contain in an array, then index and this maximum sum. So this like we have to make an array such that we have to make an array of size n. So this will be of size n, that is nothing but 4. And what we have to do, we have to put the elements in this array such that any two consecutive elements should not have difference more than one. Like you can put 1 here, then the difference is 0, and you can put 1 2. So in this case difference is 1, but you cannot put like this, here 1 and here 3, because in that case the difference will be 2. So it should not be this, it should be 1 or less than 1. So, and this is maximum sum. Maximum sum is what? If you are putting values here, so if you are putting values here, let's say in this case 1 2, then again 2, and then 1, like this, if I am putting values in this array, so the maximum sum is what? 6 here. So the elements that you are putting in the array should not exceed maximum sum. So like the values can be 6, or it should be less than 6 if you are summing up the all the elements of the array. So you have to, so I think the question is clear now. They are giving us n, that is nothing but the total elements in the array, and we have to put the elements in the array such that any two consecutive elements should not have a difference more than one. Like it can, the difference can be between two elements can be 1 or 0, and you have to put only positive elements. And they are giving one index is what? This is like in this example this is 2, so 0 1 and 2. So in this place, that is nothing but index that is given, we have to maximize the value of num we have to maximize the value of this index. So what we have to do, we have to maximize the value of this index such that all the conditions should be followed. What conditions? Consecutive elements value should not differ more than 1. The difference between two values can be 1 or 0. We have to put only positive values, and the sum of all the element cannot exceed the maximum value, that is 6 in this case. So what we can do, let's see what we can do in this case. So uh, we know the size is 4. I'm making array of size 4. I can put 1 1 everywhere. This is one case that I can, this is one thing I can think of. So I know, like at this point index 2, this is index 2, I have to maximize the value here. This is 0, this is 1, and this is 2. I have to maximize the value here, and it should not exceed 6. So what I can do, this is 1 now. Can I put 2 here? Let's see. I can put 2 here because in this case difference is 1, and here also difference is 1 between this, between index 2 and 3 and 1 and 2. Yes, 2 can be put. Can I put 3 here? Let's check. If I am putting 3 here, then the difference is becoming 2 in this case and 2 also in this case. So this is not possible. And if I put 2 here, let's say to check, like if I put 2 2 here to satisfy this condition, the difference between two integers should not exceed 1. It can be 1, it can be 0. So in this case if I sum up 2 plus 1 3, 3 plus 3 6, and 6 plus 6 plus 2 is 8. So this is exceeding 6. So the maximum, it is crossing maximum 7. So we cannot put 3 here. So in this case we checked, like 2 is something that that like 1 we can put and 2 we can put, and then 3 we cannot put. So the maximum value that we can put is 2 in this case. So let's see how we can approach this problem. So we have given three things, and that is, I told you, that is size of the array, then index, the particular index where we have to maximize the value, and maximum sum, that is that will be given to us, and the values of the element, the sum of the values of the element should not exceed this maximum sum value. So how we can approach this, let's see that. I know the value of this index, in this case the size of the array is 4. Okay, at this index 1, this is 1 guys, this is 0, this is 1, this is 2, this is 3. So at this place 1, we have to maximize the value, we have to maximize the value, we have to maximize the value. So how we can maximize the value, like what can be the search space, like what value I can put. Like I have checked 1, I have checked for 2, and then I have checked for 3, it is not working. So till what point it can go? It can go till the maximum sum, right guys? I can put 6 and rest of them I can put 0, but the condition will not satisfy, that is other thing. But the lower value that it can get is 1, and highest value it can obtain is 6. So can I treat this as a search space? Yes, I can treat this as a search space. This is the low point and this is the high point. This is the high point. And if this is low, this is high, I can do binary search. How I can do binary search? I have this search space and I can get one value. Let's suppose I am getting 3 in first case. If I do binary search like 1 plus 6 by 2, that is nothing but 7 by 2, and 7 by 2 is nothing but 3. So I will check for 3. Can 3 be placed here? If 3 can be placed here, I will check for mm, check for greater value, then I will go and check in the right space, and if 3 cannot be placed, I will check in the left search space. So this is becoming binary search problem in this situation. In this case, this is a binary search problem. So what I have explained you till now, you can treat 1 as a lower space, like you can put 1 in minimum case and you can put 6, and that will be your high point. So this is your low and this is your high, and every time you will be calculating your midpoint, and if this midpoint can be put here, I will explain how we will be checking the like condition, if it can be placed or not placed. So if this can be placed here, we will check for greater value, we will go right, and if this cannot be placed, if like 3 cannot be placed here, then we will check for lower values, so we will go left. So this is the intuition and approach that we will be using. So let's see actually the kind of pseudocode what we will be using. So what we will doing, we will be doing binary search here. Okay, so how we'll be doing binary search? We will find the mid. Mid is what? Mid is nothing but your lower plus higher by 2 or we can also write like this, right shift. Then I will check if is possible, like is possible, if this value can be put, if this value can be achieved, I will check to the right, to the greater value, I will go right, else I will go left, else I will go left. So how I can check, like how I can check this value can be put here? Simple. Like if they are saying 3, we have to check for 3, for example. So I will put 3 here, and here I will put 2, and like if we are 3, I will just like I will just uh, decrease one value every time. 3, then 2 here, then 1 here. Like this is how I will be putting the values, because I know the difference can be 1 or 0. So I will just decrease the value in the left or right. Like if this is the target index, so I will put the mid value directly here, and in the left and in the right I will put decreased value, decremented value. Like if this is 3, I will put 2 here. If one more index will be here, would be here, I would put 1 here, but this is not in this case, so I will put only 2 in the left, and in the right I will put, if this is 3 I will put 2 here, then 1 here, and if one more index will be here, I cannot put 0 because only positive values I can put, so I will put 1 in this case. So what I will do after putting values, you have seen the, if for this value I have to check, I will put decremented value in the left and in the right also. Why we are putting decremented value? Because the difference can be 1 or 0, so I am putting decremented value every time, and if this will be one more place here, so I will be putting 1, not 0. Why we are not putting 0? Because we can put only positive values. So after putting values, once you have done with that, you will be calculating the sum, and if this sum is less than or equal to your maximum sum, you can say yes, this value can be put here, and if it is satisfying for this, then we can check for higher values or greater values. Like this, we can go right and check for greater values. But the problem we will face here, we will face if we put values one by one, because the n can be very large. See here, the n can be 10 to the power minus 9, so we cannot go and put values to every index, and we cannot count the values for every index, like the counting values for every index in this case. So if the values are if the number of elements are very high, so we cannot count the, it will give TLE, time limit exceeded. So what we can do, see, we know, if we, in the mathematics, if you are familiar with mathematics, you can do easily. So let me rub this, then I will explain. Okay, so let's see how we can actually count the values. So if I wanted to know what is the sum of values till 5, if I wanted to know, if till 5 I wanted to know, let's suppose I wanted to know what is the sum of values till 5. Okay, till 5 I wanted to know what is the sum of values. So the formula is nothing but n cross n plus 1 by 2. So that is what, 5 5 into 6 by 2. This is what, 2 3 is 6, so this will be 15. And if you count 1 to 5, 1 2 3 4 5, this is what, 5 plus 4 9, 9 plus 3, that is 11, and 11 plus 3, that is 14. Sorry, 5 plus 4, that is 9, 9 plus 3 12, and 12 plus 3, that is 15. So this is how we can get the sum of n natural numbers, n cross n plus 1 by 2. If I want, if I want to get the sum of starting 5 values, I can get by this. So for any value we can get. So how this can help in this problem, like if I have 3 here, if I have 3 here, suppose, so I know if I have 3 here, I can directly use this formula. How I can use, this is nothing but n cross n plus 1, so 4 by 2. So this will be what, 2 2 is a 4, so this will be 6. And I know if this is 3 here, I will put in decremented value in the left, so I will put 2 here and 1 here, and if you will do the sum, so 1 plus 2 is 3, and 3 plus 3 is 6. So this is how I can find the sum of values, and in this case I need not to put values, I can directly find the sum. So if so in the right, how I will be getting, like in the right, it is not 1 here, 1 is not there, so how I can get that. Let's see that edge case also. Like what I am telling you is, let's rub this. Okay, so yeah, see the edge cases now. Like I have told you, we can use binary search. I have told you we can check, and then, and according to the condition we can proceed. But how we will do the sum of values, because that will be giving you TLE. See this is the main funda of this problem. Like if I have 3 here, let's suppose this is your index. What index? 0, 1, 2, 3, 4. These index you have in your array. And I know in the left I will put decremented values like 2 and 1. In the right also I will put decremented values 2, 1. Then this is the index I. So I will calculate the sum till here 0 to I, and then I plus 1 to this last index I plus 1 to n minus 1. How I can get? I have this formula n cross n minus n plus 1 by 2. With this I can get easily. If I want to get the sum till here, I can get easily by putting 3 cross 4 by 2. That is nothing but this will be 2, so 3 into 2, that is 6. Easy. But this is not that easy. Let's see the edge cases. What can be edge cases? Let me show you. If I have 3 here, let's suppose, and I have only let's suppose I have only what I can say, I have only let's suppose instead of like this, if this is the condition, then what I can do, I have to put 3 2 1, and I cannot put 0, so I will put again 1. So in this case, how I can find the sum till I have told you, first of all we will find the sum till I, and then we will find I plus 1 to n minus 1. So see in the left how we can find the sum. So if the values, like we will check two things, we will check like required left. What is required left? That is actually how much values I can have in the left. If I have mid value this, like if I have here 3, I can have 3 values, like that will be in the sequence like 1 2 3. That like the sum that we are calculating is like this sum that we were calculating, that is 6 in 4 3 we are checking. So this is for 3 to 1 till 1 to that point. How many values are there? That will be your mid value that you are passing here. So required left is what? Your mid value. Like for these values I am calculating the sum. So this is what your required value. So this is 3 in this case. Like I can have, if I have 3 only, if I have only 3 elements, then this formula works. This is like, this is only you need to check what is the sum. And one thing we will calculate, that is what have left. I think have left I have used, yes, have left I have used the variable. So it will be like convenient for you to understand later. Have left is what? How many we have in actually. So we will check, like here these are 4 values that are in the left. So I am telling 4 values I have in the left, or 4, and only for 3 values I can calculate the sum. So what I will do is I will check like how many like for how many values you can give me the sum. I'm saying for 3 values only. So what is the sum? That is 6. Like this 1 plus 2 plus 3, that is 6. And then I will check how many values are in the left. I am saying 4 values are in the left. So what I will do, I will again find the sum of this remaining value. How will I find? I will do sum of have left minus required left, that is 1 only. I will say only, so only one value is left, so I will just add this value. I will just add this value, like how many ones are in this here. Like if I have 3 ones here, so what will say, like I can like required left is 3, but have left is what in this case? 1 2 3 4. Like not 4, this is 3 here, so I will directly what add 3 in this case. But let's suppose this is not there, this is not there, only this one is there, only this one is there. So what I will do, I will just like whatever one is extra, like just add the extra ones. Nothing you have to do. After calculating these values by formula, just add up these extra ones. So like see another edge case. What can be another edge case? Like you can have what? You can have this condition also. Like if you have let's suppose array, and you have 3 here. Okay, you have 3 here, and this is your index 2. Let's suppose this is 1, this is, let's suppose 0, and this is 1. This is the case. Then you can have 2 here, but when you will be calculating like the sum with your formula, okay, with your formula, this will give 6 because it will including 1 also here. So in this case, what we will do, after calculating this sum, you have to, what you have to do, you just have to check how many values are remaining. Like you have calculated what required left is what, the values that I am calculating with the formula, that is 3. Like the formula, the value that I am getting with the formula, that is of 3 values. And what I have actually have left is what here, 2 in this case. So like is one element is remaining. So for that I will again calculate, like with the formula I will calculate. I will check like what is remaining. I will just subtract from that. So this will be what, 6 minus 1. So this will be 5. So I hope you are getting it. Like what I'm saying is, with the formula, like with this formula, you can get the values. But if this is 3 here, then this formula will give value till 1, so you have to extract this one. And if this is like let me conclude it quickly. What I'm trying to convey the point is, if you have 3 here and you have only one value in the left, so in this case when you will calculate, this will give value till this one, and you don't have this one in this case, so you have to discard this one. And in case you have what, you have like 3 here, then you have extra ones. In case you have extra ones, so you have to add this extra one, I'm saying, whether it is in the left or whether it is in the right. And let's suppose you have value in the zeroth index only. If you have the value, you have to check is that zeroth index only, you can directly add this value, nothing to do. So I hope you are getting it. Let's see the code to give you more clarity. So what I am doing is, let's see from this max value function. As I told you, we are setting up the search space. What are we are doing? We are declaring the search space for binary search. This is our step one. Then nothing. We are just doing binary search, easy binary search, and we are finding the mid value. You can do also here by 2, but sometimes it gets trouble. That's why I'm doing this right shift 1. This is also the same. Then I am checking if this value that I have calculated is possible to put. If yes, I will store in the answer, and I will check for the greater values. Like if 2 is possible to put, I will check for 3. Okay, and if this is not possible, I will check for lower values, because if 2 is not possible, I am sure the greater values, it will not possible. So for lower values only I can check. I hope this is clear. Then we will just do, let me remove this. I have put this for debugging. So let's see this function is possible, what this is doing. In is possible, we are checking like how many values can be in the left. So if I have this array, okay, if I have this array, and if I have 3 here, I will say I can have a required left value as 3. Why 3? Because I can have 2 here and I can have 1 here. Then I will check have left is what, if this is index like 2, then I will say index plus values for like if this is index 2, so then have left will be 3. So I am saying like 3 values are in the left. For that we have to calculate the sum in the left, and then we have to tell. So this is this. If this is index 0, like if for index 0 we have to check, we can directly put the value here and we can directly add in the sum. Like if we want to check like on the index 0, can 3 be put, so we can directly put 3 and add in the sum. Like this is the, like if any particular index we have to check. So we will just, what we are doing in this function, we are checking the sum in the left and sum in the right, like 0 to I have told you, and then I plus 1 to n minus 1. This is we are doing here. So if this is on index 0, we can directly sum up the value. If the values are much, for example, if this is 3, this is 2, and then we have like add up values. So what we will do, we will just calculate the value with our formula, like that, n into n minus n into n plus 1 by 2. I have told you this. And leftover additional ones we will just directly add. And if this is not the case, the case is like this: if you have 3 and 2 only, and the formula is giving value for 1 also, so we will just calculate the value and we will subtract this remaining 1. So this will calculate 6, and we will just subtract 1, so this will give 5, like this. So this is for the left, 0 to I. And then we are doing the same thing for index plus 1 to n minus 1. You will do in your notebook, you will get it. So in the last we will check if the sum that we have calculated to 0 to n minus 1, if that is not exceeding maximum sum, if that is less than or equal to maximum sum, I will say yes, it is possible to put a particular value at a particular index. And yes, you can check for greater values now. So this is how we will be doing. I hope my approach is clear to you. If you have any doubt, you can ask me in the comment. I sometimes it is not getting into your head. Just watch this video once or twice, you will get it. Do the dry run in the copy, and this formula you will get it once you will do in your copy notebook. And if you have understood, please like this video, and you can also subscribe to my channel for more such content. I will be putting more daily lead code challenge videos and contest solutions. So thank you for watching.